Hello, this is Ms. DB, and in this video we're going to go over how to do some of the work on the 10.4 worksheet. This is on surface area of prisms and cylinders. So this is the time you would want to dig out your Chapter 9 notes and those formula books you made, because you're going to have to remember how to find the area of the faces of your prisms and the circles of your cylinders. So at the top here we have the formulas for surface area and lateral area of each. It matters whether you use a capital letter or a lowercase letter. A capital L stands for lateral surface area or lateral area. A capital P stands for perimeter. The lowercase h is for the height of your prism. Remember that the bases are congruent and parallel to each other, so you sometimes have to think about the object being flipped around so that the bases are known what the base is. The lateral face does not include the area of the bases, so you really have to know what is the base, because you do not include the area of the base, either of them, in the lateral area. The surface area is the same thing, the perimeter times the height, but you have to add to that the area of the base times 2, because both bases will be the same area, so you can just multiply it by 2. Capital B is for area of the base, or base area. Capital B does not stand for base as in the base of a rectangle. It's only the area of a base. Cylinder is pretty much the same thing, except in a cylinder it's a little bit easier, because if you were to unroll this label that's wrapped around the cylinder, it would be a rectangle. And this rectangle would be equal to the diameter, well, it's equal to the circumference, which is diameter times pi, or 2 times pi times the radius. So you can use either one. And the height of our rectangle is h. There's a lot more information about this in your textbook and in the longer video, so please look at that if you have any questions about that. And then, of course, the surface area, we have to include the area of the base. Big B means the area of the circular base. We know that to find the area of a circle, you take pi r squared, so you need 2 of those, so 2 times pi times r squared, radius squared. So the first 5 questions is just for you to write the formulas here to make sure you have them correct. If you do not use the correct capitalization, whether it's supposed to be capital or lowercase, then it's wrong, because big B and little b mean 2 different things. And big L and little l mean 2 different things. All right, then we have some examples or some problems to do where you have to find the lateral and surface area of each right prism. Number 7. Lots of mistakes on number 7 in my past assigning this worksheet. The base is the triangular piece in front. Oh, I need my pen. So the base is this little piece here and the back side of it, because the bases have to be parallel to each other and congruent, and those are the only 2 pieces that are. So to find the area of the base, it is a triangle. And to find the area of a triangle, you use 1/2 little b times little h, where little b is 2 and little h is 5. So the area of one of the bases will be 1/2 2 times 5. That's the area of the base. Now that's needed for surface area, but not for lateral. For lateral, it's the perimeter all the way around the figure times the height. This will be the height of the figure, the height of the prism. Height of prism is 7, sorry. The perimeter of the prism, that big P stands for perimeter, will be the 5.4, that's one side, added to the little piece back there is the 2, so 5.4 plus 2, plus this piece right here is 5. So you'll add those together to get the perimeter, 5.4 plus 2 plus 5, and then you'll use the formula for lateral and the formula for surface area to find the rest of that. So be careful on that one. Now again, cylinders are a little bit easier because the formula does not involve having to find quite so many pieces. We have the radius of the circle and we have the heights of the cylinder. So you can look back at the formulas to plug in the parts for those. Lateral is 2 pi radius times the height of the cylinder. And the surface area is 2 pi, the same thing. This same piece again is equal to this. So if you already did the lateral, you'll have that part, plus 2 times the area of the circular base. In number 9, the base, again, is the circle parts. This thing is leaning on its side, but these are still the bases. And the radius is 4. They show that the diameter is 8, but that means the radius is 4. Now, some of these next problems are a little bit trickier because they're composite figures. And there's some hidden surfaces that we do not include when we are finding the total surface area. We don't need to use the part where the two figures overlap because that would be hidden and would not need to be included in the surface area. And sometimes you have to include a hole in the middle. So in this one, we would need the lateral area of that cylinder. So these can get a little bit complicated. You need to do number 10 and 11. So only 2 problems for these. I'll let you do number 10. Number 10 is almost exactly like this one. And there is an example like this in your book. So look back at that one. Number 11, I'm going to work on this one with you. So take some good notes here. We are supposed to find, is it the surface area? Yep, the surface area. All right, so to find the surface area in number 11, I need to have the surface area of the prism, all of that part to do, and I also need the surface area of the cylinder. Now, what will be the overlapping part? The overlapping part will be the circular region where the cylinder touches the prism. So this piece right here, I will have to subtract, or I could not include it in the first place, minus the, I'll say the circular base. All right, so the surface area of the prism, I'll do that part first. Surface area for prism is found by taking the lateral area plus 2 times the area of the base. And the lateral area of a prism is found, here's our formulas again, with the perimeter times the height. So I need the perimeter of the base times the height of the prism. Okay, so perimeter of the base times the height of the prism plus 2 times the area of the base. That's what this means. This is all going to equal the surface area. So the perimeter of the base is 3 plus 4 plus 3 plus 4. It's a rectangle. So 3 plus 4 plus 3 plus 4. The height is 2, the height of the prism. And I will add to that 2 times the area of the base. Well, the base is, again, a rectangle. And I find the area of a rectangle, you can look this up if you need, by using length times width. So 3 times 4. Now let's simplify what we have. 3 plus 4 plus 3 plus 4 is 7 plus 7 is 14 times 2 plus 3 times 4 is 12. So I have 2 times 12. So 14 times 2 is 28. 2 times 12 is 24. So if I add these two together, I get 52. Now I'm going to find the surface area of the cylinder. So my cylinder part. And my cylinder is, the formula to find the surface area of a cylinder is right up here at the top again, is 2 pi r h plus 2 pi r squared. I don't know why that word is moving with me. So 2 pi RH, that gives me the lateral, plus 2 times the area of the base, which is pi r squared. And r is 1, and the height of this cylinder is 2. So 2 pi 1 times 2 plus 2 pi 1 squared. So this is going to simplify a lot. We have 2 pi times 1 times 2 is 2, 2 times 2 is 4, so I have 4 pi plus 1 squared is 1, so plus 2 pi. That equals 6 pi, and since we're going to be adding these two together, I do need to know what that is as a decimal. So 6 times pi equals approximately 18.849. I'm going to round that to 18.85. Where'd my work go? There we go. That was weird. So that is 18.85. So far, my area will be 52 plus 18.85. But I have to subtract the area of the circle. So I'm going to subtract pi r squared. Just one area of that base. The radius is 1. So pi times 1, or 3.14. So I'll be subtracting 3.14. So altogether, I have to take 52 plus 18.85 minus 3.14. And that will be the surface area of this figure, this composite figure. Now, some of you may be asking, couldn't I just have added the area of one base right here? So instead of adding 2 pi r squared, I could just add pi r squared. And the answer is yes. And then you wouldn't subtract the 3.14, the area of one base. So there's more than one way to solve this problem. All right, the next section is not hard, but you do have to remember this. We have been working on this for months. If you change the dimensions of a figure, how does it change the area? You should know this from last chapter. It changes the area by that amount, that factor squared. Same thing for surface area, as you would expect. So if all of the dimensions are multiplied by 3, the surface area will be multiplied by 3 squared, which is 9. You don't actually have to find the area of the original and then change all of these amounts by multiplying by 3. If that question says, what is the effect on the surface area? The answer is, it will be multiplied by 9. So it's not just 9, its surface area is multiplied by 9. That's the answer. So for the next few problems, there's 4 of them, you don't actually have to find the old surface area and the new surface area. You have to know what the rule is and what the surface area will be multiplied by. So every one of your answers should start out with the surface area will be multiplied by, and then you write your answer. It's not 2. If you say the surface area will be multiplied by 2 because the length, width, and height are multiplied by 2, then that will be wrong. It's not 2. It will be 2 squared because the surface area is the same as area, and area is multiplied by that factor squared, not equal to that factor. If it's divided by, you can either switch to multiplied by something, or you can write your answer as the surface area will be divided by that factor squared. So those last 4 should take you about 30 seconds, but you better get them right. And don't forget to write a short sentence in front of it. Don't just write 4 or 12 or 144 or whatever. You need some information there about what's happening. All right, if you have any questions, be sure you let me know and I will help you out. Finding surface area can take a little while, but as long as you remember how to find the area from our previous chapter, it shouldn't be anything too complicated. Thank you very much and have a wonderful day.